Okay, so I don't want you guys to write this down. I'm just going to read what we're doing here. So it says, in this new lesson that we're starting, you will determine sums and differences of polynomials. Those are fancy math words that say add and subtract. You might say, why don't you just say add and subtract? Well, because those are the terms that will be on the SAT. So the Common Core standards that we're going to cover, basically we're going to look for and make use of the structure of these polynomial expressions. And then we're going to basically, the second one is, can we add, subtract, multiply polynomials? And factors should be in there too, but it's not in the standard. And that's what we're going to do. We're just going to do the adding and subtracting. And then the next lesson we'll multiply and factor. Okay? So moving on to the next slide, I do want you guys to write this down. And I'm going to zoom in real quick so you can see it a little better if you're way in the back. These are terms that we're going to use. Mr. Adams is going to start using, but these are the three structures that we're going to be focusing on. So a constant expression like the number 5 is just a number. We call it a constant because 5 will always be 5. There's no variation. There's no variable. There's no letter. So a constant, when Mr. Adams says, oh, the constant of 3, that means that there is no x, okay? Now, when I say a linear expression, that's the one that you guys are most familiar with. That's the mx plus b, or as they have written it here, it's ax plus b. Now, this I do want you guys to write down, okay? So make sure that you're writing this down. So this is a constant. This is a linear expression. Now, I will point one thing out, and it's going to be a little redundant, but that's okay. Linear is a first degree polynomial. That means that x is raised to the first power. We call it linear because when you graph it, it's a straight line. Okay? But it's x to the first power. Now, a quadratic expression, notice that I have x to the second power. And by the end of today, we're going to talk about, or probably the end of this example, we'll talk about what that means. Now, when I slide over, one thing that I want to highlight is when you have a term, we have different things, right? So this is 3x squared. Well, the variable is just the letter x. Now, x represents a number, but it's a variable. We call it a variable because it can vary depending on what the value of x is. If I say x equals 2, then you plug the 2 into the equation. If I say x equals -7, we plug in negative. So that x represents a number, but sometimes we change the number, so it varies. Coefficient is the number in front of the letter. Okay? Now, a coefficient is usually what we call a scalar multiplier. In other words, whatever I plug in for x here, I'm going to multiply by 3. Again, a coefficient is a number that's in front of a variable. Now, if there's no variable whatsoever, we call that a constant. So 7, the value of this term, right? And let me circle these so you kind of understand what I'm talking about here. This is what we call a term. This term varies because it has a variable. This is a term. Again, we have the coefficient and the variable. This is also a term, but it's constant because it doesn't vary at all. That term will constantly be 7. This term, 5x, -5x, that will vary based on whatever we plug in, okay? Let's, one last thing on the slide. So with all that stuff being said then, constant is like x raised to the 0. By the way, what is x raised to the 0 power? 1. So remember that this will always equal 1, right? Or some constant. So let's think of that in terms of being just a number.